statistical package of SPSS, I would like to once again request our Chief Resource Person, Dr. Chanchla Jain ma'am from Prestige University Indore, to please grace us with your valuable information for Day 6 module on SPSS. Ma'am, over to you.
Thank you so much, Shrey sir. A very good evening to one and all present over here. Firstly, thank you, Shrey sir, for always starting with a nice quote.
Thank you, ma'am.
Thank you. So I think I can start session, right, sir?
Yes, ma'am, the session can be started.
Okay, thank you so much. So give me a second. I'm sharing my screen. I hope my screen is visible.
Yes, ma'am.
Yeah, just a minute. So yesterday, as I promised that I'll complete the remaining part of the t-test today. So firstly, rather than going to ANOVA, firstly I'm taking the paired samples t-test, which is the remaining part of the t-test which I have discussed yesterday. So yesterday I have already explained that we have the two categories in the t-test, that is the one sample and the two samples t-test. One sample t-test, in that we will having only one sample, and in two samples t-test we are having two types of t-test: independent samples t-test and the paired samples t-test. Yesterday I have discussed about the independent samples t-test. In that I have explained that whenever we want to find the significant mean difference in the two unrelated or two independent groups, in that case we will apply the independent samples t-test. Now today I am going to explain paired samples t-test. So firstly we will see what this test is, what are the assumptions of this test, and then we will proceed to apply paired samples t-test using SPSS. So paired sample t-test is very useful when we want to determine whether the mean difference between two variables measured on the same subject at two different moments is statistically significant. So here you need to pay attention on these lines. It is clearly saying that first thing we want to find the mean difference. In which things we want to find the mean difference? In the two variables, but these variables should be measured for the same subject. Means suppose I have conducted one survey today on a particular sample, and after some time I'm again conducting the survey, so the sample would be the sample would remain same in the second conduct also. So that way it is the importance of paired samples t-test, that sample would remain same or the respondents would remain same for collecting the data, and at two different moments, that is at two different time intervals, we will collect this data to find the significant mean difference. So in order to run paired samples t-test, we must have two paired measurements of each subject. Now talking about the assumptions of paired samples t-test. So the first assumption is the dependent variable should be continuous in nature, that is it should be measured twice. Means for the same group of people we need to collect the responses two times, but at two different periods we need to collect that responses for this dependent variable. Then the differences between the scores of variables are normally distributed. Say for example, a particular company want to see the means particular company has organized one training for the salespersons, and now company want to check that whether that particular training has affected their sale performance or not. So now what company can do? Company can collect the performance score of the salesperson before giving the training, and after giving the training after some time period, again company can collect their performance, sales performance, and that way the company can find the mean difference, or company can find the difference in the performance of the of the salesperson, and whatever is the difference will come, we need to check whether that difference is normally distributed or not. Then the differences between the scores of the variables should not have means in that particular difference there should be no significant outlier be present. So that is the two important assumptions. The first is we need to check the normality, and second we need to check the significant outliers, and these two we need to check for the difference value of the scores. And the important one is the dependent variable should be continuous scale variable. Hypothesis for the paired sample t-test can be the null hypothesis we can formulate as the main difference between the two variable scores is equal to 0, or other way around we can say that there is no significant difference in the mean score of variable before and after the conduct of that particular test or survey. Similarly, alternatively, we can see that there is a significant difference in the mean score of that particular variable before and after the survey. So that way, these are the hypotheses, that is null and alternative hypothesis for paired samples t-test. And I think this is the thumb rule which I have already discussed, that if the p-value is less than 0.05, so this less than 0.05 value comes from your level of significance, whatever level of significance you are assuming. So you need to compare your p-value with that level of significance. And if your p-value is less than level of significance, you will not accept your null hypothesis. So now, after performing the paired samples t-test in SPSS, what things we need to report? We can report the test value, that is the t statistic value we can report. Along with that, we can report the degrees of freedom. Then we can report p-value. Also, we can report mean difference. And lastly, we can report the confidence interval of difference. So these all we will get in the output of the paired samples t-test while applying through SPSS. So this is all from the conceptual part of the paired samples t-test. Now I'll move to the SPSS window to tell you how we can perform paired samples t-test. So here I request all of you, I hope you have received the file named as math test. Is it? Everyone has received that file? Shreyas, anyone from participants will confirm me? Have you received?
Ma'am, we have not yet received any file.
Okay. Okay, sir. Just a minute. Uh, okay, I need to check. Ajay sir has checked my message or not. Ajay sir has not yet checked my message. Anyone from RFI? Yograj sir is here? Okay. Sir, will you ping me on WhatsApp? I'll share the sheet with you. And I save your number also, because I think I do not have your number saved in my mobile. Yeah, I think you have pinged me. Sir, I have shared with you. Please check it. Yeah. Sir, your name is Yograj, right? I think Yograj is sufficient. Okay. I hope now you have received the file, everyone.
Yes, ma'am.
Yeah. So I request everyone, please download and open the file. I'm giving you few seconds. I'm waiting till then. Uh, I hope people are performing along with me, right? So shall I start or shall I wait? Uh, can I proceed?
Ma'am, I guess you
Yes,
can
ma'am, you
prefer.
can proceed.
Okay. Okay. Thank you so much, sir. So in this file, you can find we have total 4 columns with the name grade 1, grade 2, before and after. So I'll perform here using the grade 1 and grade 2. Remaining you can use by your own. This can be the practice kind of thing. So this is one more extra data which is given here. So I'll explain you firstly the condition of grade 1 and grade 2. Say for example, a test, any particular teacher has or want to check what is the knowledge level of the students in that particular subject. So teacher has conducted firstly the test of to know this thing, that what is the knowledge level of the student in that particular subject before teaching the subjects to the students. So this way these are the grades which are collected by the teacher, and after teaching that particular subject, and then again teacher has conducted the test on the same class, and this is the grade 2 which is giving you again the score of the students in that particular subject scored by these students. So this way we are having these two particular columns or two particular variables, grade 1 and grade 2, in which you can find you will have the same number of data till the, I think we have total, let me check, it is 359. So we have total 359 students data. So that means those students who have appeared in the first test, they are also appearing in the second test, and this is the imperative condition for performing the paired sample speed test. As name itself is suggesting, it is paired T test. So we need to have the same pair for both we need to have the same pair for each and every cases. So these are the cases 1 to up to 359. So firstly, as a tradition, I will come here and I will write the hypothesis, that what should be the hypothesis for paired sample status. So here I am writing firstly the paired samples t-test. So the null hypothesis would be there is no significant difference in the mean scores of students before and after teaching. So this is the one way of creating or formulating the hypothesis. The other way can be the teaching is ineffective. So if these scores are not different before and after, that means teaching is ineffective. But it's still, if we are finding some changes in the score, that means teaching is effective. So this way, these are the two ways of formulating the null hypothesis in case of paired samples t-test. I hope you have noted it down. Now I am proceeding with the SPSS and we'll see here how we can perform paired samples t-test. So first thing, we need to have the dependent variable in continuous scale. So you can see we are having the grade, that is the scores, and after looking at the score values, we can understand this thing, that these scores are on continuous scale, or whenever you are taking the scores, they would always be on continuous scale. So this way, first assumption is directly we have met while looking at or by observing at the data. Second assumption was we need to check the normality of the difference of the score, and also we need to check whether is there any significant outliers available in the difference of the scores. So for testing these two assumptions, firstly we need to calculate the difference of these grades. So for that, you need to go to the transform menu for getting the difference. So I request those who are performing along with me, go to the transform menu, then click on compute variable. I repeat, go to the transform menu and select compute variable and click on this. So once you will click, the compute variable dialog box will appear in front of you. You would be able to see cursor is blinking under the target variable. So it is asking us to give the name of your target variable. Means whatever variable I want to compute here, I need to give the name to that variable. So here I am giving the name as difference because I want to calculate the difference. After doing that, you can come to the numeric expression box, and here firstly I need to shift my grade 2 variable. So I'm coming to the grade 2, shifting grade 2 using this arrow key into the numeric expressions box. Then I can, from this calculator, I can use here the minus sign. Then I can select grade 1 and I can shift using this arrow key to the numeric expression box. And this way it will calculate us or it will give us the difference of the grade 2 and grade 1. So this is all you need to perform here, and then you can click on OK to generate the difference of the grades. So can I press OK?
Yes, madam.
Yeah. So once I have pressed on OK button, you would be able to see a message is coming at the output window. It is showing us that computation has been done by the SPSS, and we can see its output in the same file under the data view. So you can see one more variable is created with the name difference, and this is the difference of grade 2 and grade 2. So this way difference has been calculated. Now further what we need to do, we need to check the normality and the outlier. So can anyone tell me now what I need to do to check normality and outliers in the difference? What I can do now? Anyone? I think we are doing this thing since last 2 days. We have been performing this thing. Can anyone repeat?
Ma'am, you want to know that steps, right, for the normality
Yeah,
test?
yeah. What I need to do here?
Yeah, first we have to go to the analysis,
Yes.
and second we have to select the scale,
Okay.
and third one we have to see the reliability analysis,
Okay.
and we have to check the statistics box,
Okay.
and here we can histogram, correlation. Here we have to see that histogram and that
I think I am unable to find your histogram, sir. I think Shivanand sir is talking to me, right?
yeah, yes ma'am, yes ma'am.
Yeah. Okay. So any correction or anyone wants to add something here? Is it correct way? Yes, dear friends, please say something because I think since last 2 days we have been working on this. So I'm expecting now you should be through with these steps. Yes. Okay. Thank you so much, Shivanand
Ma'am,
sir.
ma'am, just a
Yeah.
minute. Yeah, here we have to go to the analysis and compare mean, and dialog box will be appear there, dependent test and dependent list and factor list. So in the dependent list, we can select any one scale, either grade 1, and the factor list grade 2, and we can go to the plot dialog box, and we can see there a histogram, and through that we can continue the normality test, ma'am.
So will you please repeat, Shivanand sir? Go to the analyze menu, then compare means. Is it? Subhash sir is here. Subhash sir. Subhash sir is here or not? Okay. Anyone else who want to add something here? No. I think I am expecting this because I am teaching this thing since last 2 days. So I am expecting now that you people need to either make notes, because this way it would be difficult if you are not making. I think this is my own experience. Whatever we are learning, if we are making notes in our own language, that way it will always be helpful for us to refer the same notes in the future. So again, I request all of you, if you have not made your notes so far. So again, I'm repeating the process of checking the normality of the data and outliers in the data. We need to go to the analyze menu, then we can go to the descriptive statistics, and then we can select explore. Again, I repeat, analyze menu, then descriptive statistics, and then explore. And then you need to click on the explore. So I hope, is it fine, or do I need to wait? If you people are noting it down, can I proceed?
Yes, ma'am, you can proceed.
Yeah. So once you will click on the OK button, you would be able to see the explore dialog box. Here we are interested in checking the normality of the difference variable. So I have selected this and I'm shifting it to the dependent list box. Then I can come to the plots button. Here I can deselect the stem only. I can select histogram and I can check this box, that is normality plots with test. And then I can press continue. And then I can press OK to generate output. So you would be able to see output is coming in the output window for the explore, and then you can check for the difference. We have total 359 observations. Nothing is missing value. So the total is same. Coming to the descriptives, you can find the mean difference is 1.1767. The median is 1.19. So the difference is very close, or these mean and median are very close to each other. Then coming to the kurtosis and the skewness value, so these both are negative, but these are in the range -2 to 2 and +3, sorry, -3 to +3. So these two values are in the range, in the threshold range. So maybe on the looking at the mean and the median and also looking at the skewness and kurtosis, somewhere we can say that the difference is normally distributed, but still we will wait for the Shapiro-Wilks test. So you can find here the Shapiro-Wilks test and its significant value. So its significant value is 0.108. So can anyone help me to interpret this Shapiro-Wilks test results? Anyone? Yes. What would be the conclusion? Can anyone tell me? Yes. Anyone? Okay. So after looking at the Shapiro-Wilks test, the significant value is 0.108, which is greater than 0.05. So here we can reject the null hypothesis, we can accept the null hypothesis of Shapiro-Wilks test, and we can conclude that the difference is normally distributed. So that means now the results or the interpretation of output of Shapiro-Wilks test is also in alignment of the skewness and kurtosis value interpretation. Going to the histogram, you can see histogram is again saying that it is approximately normally looking histogram. You can, if you want to put here the bell-shaped curve, you can double click here and you can use this distribution curve. Then you can close this, and you would be able to see the normal distribution curve on the histogram. And after looking at the normal distribution curve, we can say approximately that the difference is approximately normally distributed. Coming to the QQ plot, you can see most of the data points are following this normal line. Few deviations which we can find here, only 2-3 points we can see here, and 2-3 points we can see at the left hand side. So approximately looking at the QQ plot also, we can see that the difference is approximately normally distributed. Now coming down, talking about the significant outliers, you can see at the box plot. So looking at the box plot, we can see at the upper side or beyond the upper whisker, we are not finding any of the outliers. But at the lower whisker, we can see, or beyond the lower whisker, we can find some of the outliers. So these are coming as the circles. These are not the asterisk sign. So we can say that these outliers are not significant. So that way we can conclude that all the assumptions of paired samples t-test have been met by the data. And now we can perform the paired samples t-test on this data. I hope it is clear to everyone. Please be interactive. I think it is little difficult in teaching through the online modes. So I expect friends to please be interactive during the deliberations. So it would be little easy for me also to connect with all of you.
Ma'am, if you don't mind, can you just show us the histogram with the bell curve, ma'am?
This one?
Yes, ma'am.
Okay. So anything else you want me to explain here?
No, ma'am, I got that.
Okay. Okay. So can I proceed now?
Ma'am, using linear regression, linear part also, we can have blocks, QQ part also, na? This is
Ma'am,
also
your
part of
voice
linear,
was,
na?
will you
QQ
please
plot.
repeat? Ma'am, your voice is not coming properly.
Can you hear me right now?
Yeah.
Can you hear me now, ma'am?
Yes, 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 ma'am.
Ma'am, this particular QQ plot is also can be used in linear regression में भी देख सकते हैं ना ये जो
Ma'am,
आपने
it
ये
is
linear regression.
it is depending because this is the normal distribution curve, or this is the
Yes.
normal quantile plot. So if you
Yes.
want to check the normality of the variable in the regression also, in that case also you can plot this.
Okay.
Yeah. So it is not like for regression, for t-test, for ANOVA, for anything, you can use this thing to check the normality of your variable.
Okay, ma'am.
Okay. So now I'm proceeding with the paired samples t-test. So for applying paired samples t-test, we need to go to the analyze menu. Then we can go to the compare means. And then from here, we can select paired samples t-test. So I request everyone, you can note down, go to the analyze menu, select compare means, and then select paired samples t-test. And after selecting this, you can click on this, and that way the paired samples t-test box will be in front of you. Now what you need to do, you need to shift your variable from left side to the right side. So what you can do, you can select your grade 2, means whatever is the post performance, that you can select first and shift it to the variable 1 box. Then you can select the initial performance, and then you can shift it to the variable 2 box. So this is what you need to do here, or these two shiftings you need to make here to shift your variable from left side to the right side. Is it fine? Can I proceed? Yes. Yeah.
Yes.
Then you can click on the thank you, sir. Thank you, ma'am. So now you can click on the options button. So here again, you do not need to touch anything. It is showing us the confidence interval percentage, which I think we have seen yesterday also. So it is 95% by default. If you want to make any changes, so that you can make here. But usually in social sciences, we can check the hypothesis at 95% or at 5% level of significance. So I'm okay with this. I'm not making any changes here. For missing case, SPSS by itself going with the first by default option, that is exclude cases, analysis by analysis. So it is okay with us. It is not impacting our results. So according to the paired sample status, whatever is a suitable option, that the SPSS will choose. So that way you can press here on the continue button, and then you can press OK to generate the outputs. So once you will press OK, output will be generated now in the output window for the paired sample status. So the first table which is coming here, it is the paired samples statistic. This is the descriptive statistics for the data. So you can find here we have shifted two variables, grade 2 and grade 1. So for both the variables, these are the mean scores in both the groups, grade 2 and grade 1. Total observations or total respondents were 359. Now the standard deviation of the grades were 0.188 and 0.48. This is for the grade 2 and this is for the grade 1. This is the standard error of mean. Now coming to second table, it is showing us the paired samples correlation. So whenever we will perform paired samples t-test, always we will get the correlation value. So whether this correlation value is significant or not, we need to check this. So it is showing us that significant this correlation is not significant because the significant value is coming as 0.894, which is greater than 0.05. So which is indicating that the correlation is not significant, but it should be significant in case of paired samples t-test. So for the sake of interpretation, I am telling you how you can interpret the results of this paired samples t-test, which is the last table in the output window. So here you can check. So here you can check the difference of the grade 2 and grade 1. The main difference is 1.17667. The standard deviation of this difference is 0.51668. Then standard error of mean is this 0.02727. Then 95% confidence interval values, lower and upper limit is coming here. And finally, the t value is 43.150 for 358 degrees of freedom. And the significant value of the t-test is 0.000. So which is greater than, which is less than 0.05. So that means we can reject the null hypothesis of the paired samples t-test. And I think you can recall the null hypothesis which we have formulated here. So we are rejecting this. So we can conclude here that there is a significant difference in the mean scores of students before and after teaching. Or other way around, I can say that teaching is effective. So this way, this is the interpretation part of the paired samples t-test. So this is all from my side in case of paired samples t-test. Any doubt so far, or can I move for ANOVA now?
Madam, just one thing. In this case, we are rejecting the null hypothesis. But
Yes,
if we were to conclude it practically, this teaching could be effective negatively or positively. That also needs to be determined. Because if these scores have dropped, then teaching has in fact proved to be teaching has given us negative result. And if our scores have improved, then teaching has given us positive result.
Yeah,
So
that you can check
that
here,
also
sir.
needs to be seen.
Yeah,
Pardon,
so
ma'am?
that you can check here from your mean value, sir. You can check the grade 2 mean is 7.19, grade 1 mean is 6.01. So it is quite, I think, understandable here that grade 2 mean is more in compared to the grade 1. So it is showing us that after teaching grade has improved and the mean grade has improved. And this way you can see this is the mean difference of the grade, which is positive value, which is showing us that the teaching has improved and it is positively the scores has improved and it is positively improved.
Okay, ma'am. Okay, thank you.
Yeah. So that is why I think there are two ways to perform just a minute, I'll show you here. So sometime it happens. Usually, when we look at the videos or even in some books, also you can find. Generally, people can find like this also. They can shift the grade one in the variable one list and grade two in the variable two list. When I press OK, you can see the t value will be negative here and also the mean will be negative here. But what you need to do, you need to look at the values in the first table, that is the descriptive statistics table. So here you can see that the grade 1 mean is 6.01 and grade 2 mean values is 7.19. So it is quite clear from looking at these two values that now grade has improved or mean grade has improved after teaching to the students. So that means this is the positive impact of teaching on the grades, right? So that is why I told you people that usually we need to shift the second, means whatever is the post outcome, that we will shift first, so that if it is the positive impact, we will get all the results positive. And usually t value should not be a negative value, and this is also the one more important thing we need to keep in our mind. So that is why I suggested you to shift grade 2 first and grade 1 lastly.
Okay, ma'am. Yes, ma'am. Thank you, ma'am.
Yeah. So I think this. Any other query regarding paired sample status, or should I, or shall I move for the one way ANOVA now? Yes. I think no more doubts. Okay, thank you so much, everyone. I think no doubt so far. I'm coming to now the next agenda of the day, that is the one way ANOVA. So give me a second. I want to SF5 here. Yes. So now we are discussing one way ANOVA. So before proceeding with one way ANOVA, I want to again repeat one thing. I think yesterday, I think I can recall yesterday I said this thing. When we talk about the paired sample status, in case of, sorry, when we talk about the independent sample status, in case of independent sample status, we should have two categories in the independent variable, or we should have two labels in the independent variable to perform independent sample status. But question comes, if we have more than two labels or two categories, so what we can do? Can we apply independent sample status? Answer is no, because capacity of independent sample status is it can compare only two unrelated groups, or it can compare only two unrelated categories, or it can compare only two unrelated groups. So that way, this is the main limitation of the independent sample status. So that is why if you are having an independent variable which is categorical in nature, and suppose it has more than two categories available, so in that case, if you want to compare the main difference in those three groups or four groups, in that case, we will go for the one way ANOVA instead of performing independent sample status. So this is the major difference between one way ANOVA and the independent sample status. So when I talk about one way ANOVA, it is given by Sir Ronald Fisher. That is, he was the British statistician. He has given this particular one way ANOVA, and after his name, that is Ronald Fisher. So we can take the first alphabet of his last name, and that is why you would be able to see when we will perform one way ANOVA in SPSS or in any other software, we will get the F statistic. So this particular test helps us to find out the significant mean difference between two or more than two groups. Means if you are having two groups, in that case also you can perform one way ANOVA. But if you are having more than two groups, in that case also you can perform one way ANOVA. So that means independent variable may have more than two labels or two categories. In that case, we can perform one way ANOVA. Say for example, if we want to see a teacher, or our teacher is teaching in our teacher is using three different techniques to teach the students. So the techniques can be through the audio mode, he is teaching to the students; through the showing the video, he is teaching to the students; and by doing the discussion with the students, he is teaching to the students. So that way, using these three different techniques, the teacher want to see which particular method or which particular pedagogy has more impact on the learning of the students. So that way, if the student or if the teacher is interested in finding such kind of impact on the learning of the students, so that way he or she can opt for the one-way ANOVA. Next thing, ANOVA is a precursor to the general linear modeling, that is the regression. I think it is the last session which I'll take tomorrow. In that, I'll discuss the correlation and regression. So when I'll explain you correlation and regression. So we will see in the output of regression, we will also get the ANOVA value. So that is why it is written here that ANOVA is a precursor to the general linear modeling. That means to check the linear relationship between the two variables or more than two variables. Generally, ANOVA comes as a precursor or ANOVA comes as an output in the regression also. So that is why it is also important from the point of view of regression analysis. Now, talking about one-way ANOVA, when you can use one-way ANOVA, whenever we are interested to find a statistical difference among the two means of two or more than two groups, whenever we are interested to find the statistical difference among the means of two or more than two interventions, whenever we are interested to find statistical difference among the means of two or more than two change scores, in that case also we can perform one-way ANOVA. Now, the variable requirement for one-way ANOVA. So to perform one-way ANOVA, we should have two variables, the dependent variable and the independent variable. So the dependent variable should be continuous in nature. Independent variable can be categorical in nature, and it should have at least two or more than two categories. Now, as I said, dependent variable should be continuous, independent variable should be categorical in nature, but at least three labels should present in the independent variable. Example can be, if I want to see, just a minute, if I want to see the performance, I want to check the performance of the students, those who are learning through these three different methods. So performance we can check with the help of their marks scored, and these are the three different methods through which they have learned any particular subject. So that way, here we can see marks can be the dependent variable, and it is a continuous scale variable, and these three are the categorical variable or nominal scale variable. In that we are having the three categories: the discussion, audio, and video. Now talking about the assumptions of one-way ANOVA. So the assumptions of one-way ANOVA, the first one is assumption of independence. It means two or more independent groups that represent independent variable should be categorical. So we should have two categorical variable, we should have two categories in the independent variable, and for both the categories we need to be careful that we should collect observation or data only once per individual to meet this particular assumption. Talking about the next assumption, that is the normality. So your dependent variable should be normally distributed. So this is the important assumption in case of one-way ANOVA. Then assumption of homogeneity of variance. So the assumption of homogeneity of variance, it is we can check using the using the Levens test, or if this particular assumption is not satisfied, that means this assumption is violated by the data for of one-way ANOVA. In that case, we can perform the Welch test also. So in SPSS, this test is already given there. I'll show you. And last assumption is there should be no outliers, or there should be no significant outliers in the dependent variable. Now question comes, if assumptions of one-way ANOVA have been not met by the data, in that case what we need to do? Either you can go for the transformation of your data, or if not, you can opt for the non-parametric test. And for one-way ANOVA, the non-parametric test is Kruskal-Wallis test. I think this is, I have shown you yesterday also. This is the histogram when we will check the normality of the variable. If the variable is showing us this kind of graph. That means it is showing us that the variable is approximately normally distributed. Talking about the Levin's test. So for Levin's test, the null hypothesis is that the variance of all the groups, whatever number of groups we are having in the independent variable, of all the group, the variance is the same. So this is the sigma square. I think you are knowing symbolically variance is represented by sigma square. So sigma square sigma 1 is square, sigma 2 is square, sigma 3 is square. So say for example, if we are having only 3 groups in a particular variable, so we are assuming in a null hypothesis that in all the groups variance is same. Alternatively, we are saying that the variance is not same in the any of the group or in at least one of the group. So this way, this is known as the hypothesis for the Levin's test. So if we want to achieve the assumption, one of the important assumption of one-way ANOVA, so for that, our data should support the null hypothesis of Levin's test. Now, talking about the hypothesis of the one-way ANOVA, so we can formulate our hypothesis like H naught can be mu1 equals to mu2 equals to mu3. That is the group mean, whatever groups we are having. So all the group mean are equal. This is the null hypothesis. Alternatively, if one of the group mean is not equal, at least one of the group mean is not equal, even in that case, we will say that this is the null alternate hypothesis, and we will like at least one of the K population mean is not equal to the others. But which group mean is not similar, that I think that is the drawback of one-way ANOVA. It will not tell us that, and to check that, I'll tell you in SPSS what you need to do. This is the table which we will get as an output of the one-way ANOVA. In that, you will get the sum of squares for the row. Means for the row, if your data is available through this, it will give you the means between and within also. When we will get the output in the SPSS, it will come in terms of between and within, because between the groups, whatever groups we are having, in those groups we will check the difference, and within the group means whatever the groups are available, if they are listed in column, so we will see whatever the difference in the within group. So that way, these are the two things will come here: sum of squares, then their degrees of freedom, and then mean sum of square, and that way we will calculate the F value. So this is the table generally we will also get in the SPSS output of the one-way ANOVA. Now, how you need to perform the one-way ANOVA in SPSS? So these are the steps. So that I'll tell you when we'll go to the SPSS. So this is all from the theoretical point of view of SPSS. Now I'll proceed with the file which I have already shared with all of you. I think yesterday we have also worked on this file. The file was named as employee data. So I have opened here the same file, and we will work on the same file to apply one-way ANOVA. So I request everyone to open the employee data, and we will perform one-way ANOVA on this file only. So I hope those who are performing, they are opening it. Is it with everyone? Yes, anyone will confirm me? Am I audible?
Yes, ma'am, you're audible.
Yeah. So I hope it is available with everyone.
Yes, ma'am, it might be available. If it was shared yesterday, it would surely be available with everyone.
Yeah, I think we have worked also on this file. So I am expecting that it would be available with all of you. Okay, I think participants are not interested in interaction. So I am proceeding with the performance of the one-way ANOVA in SPSS. So this is the data set available with us. Now we need to identify, as so many variables are available on this file, which variables we will opt here. So you can check here. First variable is the gender. So it has only 2 categories. So that way we cannot perform one-way ANOVA on this. So we need to have at least 3 categories to perform one-way ANOVA. So I'm taking here the job category and the salary. So these are the three job categories. I need to check. I think job category, yes. You can find here in the job category, one is stands for clerical, two is for custodial, and three is for manager. So these are the meaning of the numbers 1, 2, 3. Means first one is representing the clerical staff, second is representing the custodial, and third is representing the manager employees. So this way, these are the three categories available under the job cat. So we will perform our one way ANOVA on the job category and salary. So for performing one way ANOVA on these two variables, firstly I let you know how you can write the null hypothesis for one way ANOVA. I'm writing there is no significant difference in the mean salary of employees belonging to various categories, or you can write there is no significant difference in the mean salary of clerical, custodial, and managers. So this is the way of formulating your null hypothesis in case of one-way ANOVA. So now, how to perform one-way ANOVA? I'll let you know in SPSS. So I am on the SPSS file now. Firstly, what we need to do, we need to check the assumptions of the one-way ANOVA. So coming for checking the assumptions of one-way ANOVA, I'll click here on the Analyze menu. I'll click on the Descriptive Statistics. Then I'll select here the Explore. So I repeat, go to the Analyze, then Descriptive Statistics, and then Explore. Click here. Now you can reset this because previously probably I have used this. So this was already set here. So I have reset this. Now I'm shifting my current salary to the dependent list box. Then I'm shifting the category. Where is category? This is the job cat, which I'm shifting to the factor list box. So this way I have shifted my both the variable at the specific location. Now what I need to do, I need to click here on the plots. Here I can deselect stem and leaf. I can select histogram. Then I can select normality plots with test. And then I can press continue. So this is only thing I need to do here. And then I can press OK here to get the output. So now you can go to the output window and you can check. We are getting here the results of Explore, and first table is coming as the summary table. In that we can find the current salary of the clerical, custodial, and the manager. And in all the three categories, first thing you can check, clerical staff is 363 in number, custodial is 27 in number, and managers are 84 in number. Then nothing is coming as missing value. So whatever is the valid values, these are the total values. Going down, now you can check. Now according to the category or job category, you are getting the descriptive statistics for the current salary. So now firstly we are looking at the mean salary of the clerical staff. So you can find the mean salary is $27,838.54 for the clerical staff. When we talk about the custodial, the mean salary is $30,938, And for the managers, the main salary is 63,977. Now you can check by looking at these figures. Now you can check the skewness and kurtosis also. So skewness and kurtosis is saying that skewness is very close to the +2, but kurtosis is very far from +3. Both, although both are the positive figures, but kurtosis is very beyond to the threshold range. So that is why probably we can say this thing, that there is some problem with the normality of the current salary for the clerical staff. Now you can check the mean and the median value also. So there is a slight difference, approximate 1000 or something difference it's coming in the salary of in the current salary, or in the mean current salary and the median current salary. So that way also we can say probably there is the salary is not normally distributed for the clerical staff. Going down, looking at the custodial staff current salary, you can find here skewness is in the range, but kurtosis is again going beyond the range. It is exceeding the 3. So that way we can conclude probably again that the salary for the custodial staff is again probably not normally distributed. Looking at the mean and the median salary for the custodial staff, we can check that the difference is not quite or difference is not much bigger. They are nearby, but we will look at the Shapirovil's test to conclude something for this. Going down, we can check the manager. For manager, again you can check the skewness and the kurtosis value. Both are coming in the range. Skewness is in between -2 to +2, and kurtosis is in between -3 to +3. So that way we can conclude probably might be that we can say that the current salary for the manager might be normally distributed. Now looking at the mean and the median value of the current salary for the manager, so we can find a difference here, almost 4,000 approximate difference is coming here. So it is saying us that maybe there is some again dilemma. It is showing some dilemma in the normality of the salary for the managers. Going down, check the normality using the Shapirovil's test for all the 3 categories. So we can find for all the 3 categories significant value is 0.000, so which is less than 0.05. So if it is less than 0.05, that means we are going to reject the null hypothesis of the Shapiro-Wilks test. And probably you people can recall in the previous session I discussed this thing, that for Shapiro-Wilks test, the null hypothesis is variable is normally distributed. So for all the 3 categories, we can conclude that current salary is not normally distributed. So this way, this is we have declared using the Shapiro-Wilks test. Now going down, looking at the histograms. So histogram for the first category, that is the clerical, it is saying the same story, that if we will keep here the bell-shaped curve, so that means it is showing us that the salary is the rightly skewed salary in case of the clerical staff. Means there are very less number of clerical staff, those who are getting a handsome salary or the good salary. So I'll double click on this. I'll put here the distribution curve. I'll click on this. Then I'll close this. I'll close this also. And that way you can compare the tails of this bell-shaped curve, which is saying the story that the salary is rightly skewed in case of clerical staff. Going down, for custodial, I think it is not properly saying anything, but still we are keeping double click on keeping the bell-shaped curve on this, closing this, and then you can see that here we can find that the left tail is little bigger as compared to the right tail. So probably the salary for the custodial staff is left skewed. Going down, the manager's salary, again it is showing like it is a rightly skewed salary. Double clicking on this, putting the distribution curve on this, closing this, Closing this. Now you can compare the salary. Sorry, you can compare the tails of this bell-shaped curve. It is showing us that the right tail is bigger than the left tail. So that means again we can conclude for managers that the salary is the rightly skewed salary. Now going down, looking at the QQ plot. So I think this is we have seen on the second day when I was discussing the reliability and the normality of checking of the data. So in that I have shown you the few diagrams in the slides. So this is the same shape which is showing that the salary is rightly skewed in case of the clerical staff. In case of custodial staff, it is the left skewed salary. In case of manager, again it is rightly skewed. Detrended normal QQ plots, we do not need to interpret. We can skip them. Coming down and looking at the box plot. So you can find here for all the three categories, we are getting the box plot for the current salary. It is showing us that for the clerical staff, you can find there are two significant outliers available because two asterisks we can see here. Then looking at the custodial staff salary, you can find there are at the left side also and at the right side also, at both the tails we are having the significant outliers available for the custodial staff in the current salary. Going to the last category, that is the manager, only one person we can find here with the highest salary. So this is the manager who is showing us that is the significant outlier, that is the case number 29. So this way we have seen all the assumptions of the one-way ANOVA, or we have tested all the assumptions of one-way ANOVA. So in spite of violation of the assumptions, I'll proceed to give you the demo of one-way ANOVA with this data set. So now how to perform one-way ANOVA in SPSS? For that, you need to go to the analyze menu. Then you can go to the compare means, and from here we can select one-way ANOVA. So I repeat, go to the analyze menu, then select compare means, then select one-way ANOVA. So I'll click on this one-way ANOVA now to open it. Now this box would be open here. It is asking us to supply dependent variable in the dependent list and the factor that is independent variable in the factor list. So now current salary is our dependent variable which I am shifting to the dependent list box. Job category is the independent or the factor variable which I am shifting to the factor box. This is the two shiftings you need to make in the dependent list and the factor box. Now you can come to the post hoc. So I think this is not the use firstly, because I'll let you know the post hoc, it is the multiple comparison. So I'll let you know afterwards, because once I have clicked on this, you would be able to see two things. First is the equal variances assumed, and second is the equal variances not assumed. But we are not knowing this thing because this assumption we have not checked yet. So you need to cancel this. You need to click on the options, and then you need to click here on the descriptive, and you need to click here on the homogeneity of variance test. So when we will click here on the homogeneity of variance test, it will check the last assumption, homogeneity of variance available, or the equal variance is there in the data or not. So that you need to check here only. Once you will check this, on the basis of its output, we will select the post hoc test. Now you can see, as I was discussing in the conceptual part during the discussion I made with the help of slides, in that I shown you the Welch test. So if this homogeneity of variance test is not met by the data, in that case we can select this box also, and this will give you the Welch test result. So that way you can report this Welch test in place of this. So you need to firstly check homogeneity of variance test. So I am clicking on the continue, and then I can press on the OK button to generate the output. So once I have done okay, I think you would be able to see the results of one-way ANOVA. So the first table is the descriptive statistics table, which is showing us that in the clerical, custodial, and in the manager category, we have total 363, 27, and 84 corresponding respondents, and in total we have total 474 respondents. Talking about the mean salaries of all the three categories, people, you can see 27,838 for clerical, 30,938 for custodial, 63,977 for manager. This is the standard deviation of the current salary for all the three categories. This is the standard error for all the three categories. This is the confidence interval for mean. This is the lower limit. This is the upper limit. Generally, there should be the same sign in both the categories, lower and upper. So I think that you can check here. Then minimum salary and the maximum salary for all the three categories is written in the last two columns. So this way, this is the descriptive statistics. Now talking about the next table, which is telling us the homogeneity of variances. So here, current salary means salary is our continuous scale variable. So you need to report your results based on the mean. So here you need to check the first row significant value, which is less than 0.05. So I think you can recall I have shown you in the slides the null hypothesis for the 11th test, that is the homogeneity of variance. It was that the variance is same in all the groups. So that was the null hypothesis. So here we are, not accepting the null hypothesis as the p value is p, that is significant value, or the p value is less than 0.05. So if p value is less than 0.05, that means we are going to reject the null hypothesis. So if we are rejecting the null hypothesis, that means we are concluding this thing that homogeneity of variance assumption is not met by the data. So this way we have taken an idea of the homogeneity of variance. So once we will go to the post hoc, so I'll tell you in which family we need to go. Now coming down, talking about the ANOVA table, it is telling us the sum of squares. I have shown you already in the slides, degrees of freedom, mean square, and F. So whatever is the sum of square, its respective degrees of freedom. So means when I divide the sum of square by its respective degrees of freedom, I will get the mean square value. And then similarly for the within groups also. And then between groups mean square, we will divide by the within groups mean square. So we will get the F value. And then this is the F value and its respective significant value. So we need to look at the significant value, which is less than 0.05. So that means we are going to reject the null hypothesis of the ANOVA. And I think you can recall we have made the null hypothesis like this. So now we can conclude that there is a significant difference in the mean salary of clerical, custodial, and managerial staff. So that way, this is the conclusion which we have drawn. Now question comes, just a minute. Now question comes that in which category that difference is significant. So this is the drawback or the limitation of the one-way ANOVA. One-way ANOVA will not compare in which pair that difference is significant. So for the purpose of that, we need to go to the post hoc. So again, I'll go here and click on the one-way ANOVA. I'll use this shortcut handle and I'll click on this one-way ANOVA. And now I'll let you know what is the use of post hoc. So post hoc test is what? It is the multiple comparison test. It will compare all the pairs. You need to click on this button. Here I have stopped you previously as I told you that we are not knowing whether the variance is equal or not. So that we have checked that variance is not equal. So that means it is quite clear. You do not need to go to this category now. You need to go to this particular second category, equal variance is not used. But if suppose variance was equal, so in that case, suggested one is the Tukey. So you can select Tukey if the equal variance was met by the data. Means your in all the groups the variance is equal. In that case, you will go with the Tukey test. But in our case, variance was not equal across all the groups. So you need to click here on the Dunnett's T3. These are the most used tests and these are the most suggested tests by the researchers which we need to opt for in case of equal variance is not assumed. I have told you this one is the Dunnett T3, and in case of equal variance is assumed, you need to report the or you need to select the 2 key test. And then you do not need to touch anything. You can press only continue and then you can press OK to generate the output. So first 3 tables I have already explained you. As one more thing, if the ANOVA results are significant, only then we will perform post hoc. If the test results are insignificant, means if the ANOVA table ANOVA test is saying that there is no significant difference. So when difference is not existing, so that means we will not compare the pairwise differences. But if difference is significant, because this result is saying that the ANOVA results are significant, that means the pairwise comparison is required now. So that is why we are going with the post hoc test. Now you can compare here, you can come here and you can check. So the first category is the clerical category, which is compared by the custodial and the manager. So you can look at here, the difference in the salary of the custodial and the clerical staff is this. This is the main difference. This is the standard error. And now you can check, this is the significant value. So that means it is saying us that there is a significant difference in the mean salary of the clerical and the custodial staff. Similarly, when I compare the salary of the clerical staff with the managerial staff, so the significant value is again less than 0.05. So I'll conclude here that there is a significant difference in the mean salary of clerical and the managerial staff. So that way you have made 2 comparison. First pair we have made comparison in the clerical and custodial. Second we have made in the clerical and manager. Only comparison we need to make now in the custodial and manager. So you can come down and you can check custodial and clerical already we have checked. So we will compare only custodial and manager here. So now you can check for this category also the significant
Hello, ma'am, your voice is not audible.
am I audible, sir?
Yes, ma'am, now you're audible.
Yeah, sorry, sir. I think there is a light issue. Wi-Fi has
No
now
issues.
not available. Yeah. So is it visible? My screen is clearly visible, right?
Yes, ma'am, it's visible.
Yeah. So now I think I have explained this thing that using the one-way ANOVA, how we can make the multiple comparisons also. So one-way ANOVA has a limitation. It will not tell us the multiple comparison. So to make the multiple comparison, we need to use the post hoc. So this was the all about the one-way ANOVA from my side. Only one thing is left here, which I want to tell you before taking the question for today's session, so that I explain you that how we can perform independent sample t-test using one-way ANOVA. So in SPSS, this facility is available. So for that, I'll click on this shortcut handle and I'll select here the one-way ANOVA, and then you can check. Just a minute. I have closed my video as I am using my mobile phone. So I don't know up to what level I would be able to use my mobile data. So that is why I have closed my video. So now I let you know how we can perform here the independent sample status using the one-way ANOVA text dialog box. So for that, to performing the independent sample status, we need to click on the contrast button. So I have clicked on that. Now you would be able to see the contrast dialog box. Now what you need to do? You need to come to the coefficients here, and in coefficient, suppose I think we all are knowing because I have already discussed one-way ANOVA with all of you. So we are knowing that there are 3 categories available. First category was the clerical, then custodial, and last one was the manager. So can any one of you tell me using independent sample t-test which 2 category I should compare now? Any suggestion?
Ma'am, clerical and managerial.
Okay, clerical and managerial staff. I'm comparing now. Thank you, sir. So I think we are knowing this thing in the data. Clerical staff, we have given the first position. Second one was the custodial, and third one was the manager. So now, what I need to do? Suppose I'm representing the clerical by one. So I have clicked on the add button. Now for second category, because I do not want to include the second category, so for that category I need to write here 0, and for the third category which I want to compare with the first category, I need to write the same number with the minus sign. So it is not necessary whether you need to write 1, you can write any number here, but the condition is that whatever number you will write for comparing the first category with the second category, same number you need to write for the second category also, but the sign would be changed. Plus and minus sign would be there. And then you can press continue. And again, one more thing you need to see here, that is the coefficient total should always be 0 if you want to perform independent samples t-test in one-way ANOVA using this contrast dialog box. So then you can press continue, then you can press OK. Once you will press OK, as we have not changed the remaining settings, so that is why you would be able to see all the results along with one more extra table named as contrast test. So here you can see we are getting the results of T. So you can see we are having the two contrast. We are comparing the two contrast, but here you need to remember apart above this table we are getting clerical is 1, manager is 1. So it is clearly showing that telling us that we are comparing here the salary of clerical staff and the managerial staff. So these are the salaries, these are the contrast salaries. These are the T values, and these are the degrees of freedom. So as the variance was not equal, so we need to report the does not assume equal variances. That means we will go with the second row here, and this would be the T value. This is the degrees of freedom, that is 89.708, and the significant value is 0.000, so which is less than 0.05. So we will conclude here that there is a significant difference in the mean salary of clerical and the managerial staff. So this way we can perform the independent samples t-test using the one-way ANOVA contrast button. So I think this is all from my side for the day. If you have any queries, all the queries are welcome now.
Thank you so much, ma'am. Do we have any queries for today's session? If we have any queries, participants may please come up and ask your queries.
Ma'am, it's not a query, but it's a small request. If you can share your mail ID, we can drop your questions with regarding to our research work, so that you can help us out in a better way. Or we are on the right track or not, we can get an idea. It will be better if you can.
You can note down my mail ID, but the thing is, as I am little busy, I am also working in an institute, but still if you want to have my mail ID, you can note it down. My mail ID is Chanchla. Okay. Is it fine, ma'am?
Ma'am, chanchala@gmail.com.
No, just a minute. I am giving you the personal mail ID, that is which I was telling you, that was the official mail ID. So I have given you this.
Chanchla ma'am has shared the mail ID in the chat box. Can please refer to the mail ID from the chat box, ma'am.
Thanks a lot, ma'am. Thank you very much.
Thank you, everyone.
So I guess, ma'am, we have no queries. So thank you so much for the wonderful session that you gave on SPSS. I'm sure
Thank you.
the 7 days faculty development program will surely benefit the scholars, professors, researchers, and the members working everywhere. So thank you so much, ma'am. So we'll once again meet tomorrow at 5:30 p.m. So good day, everyone.
Thank you so much, Shrey sir, and thank you all the participants for the patient learning and listening with me. Thank you so much.
Thank you, ma'am.
Happy
night.
Holi to everyone.